Good afternoon, everyone. I'm Amaury Leroux, Marketing Coordinator at Roden Schwartz Cybersecurity. Thank you all for attending this webinar. We are very happy to welcome you for this presentation, and we hope it will meet all your expectations. So welcome to this webinar entitled Boost Your Cloud Native Applications with Automation. You will be in the company of Jean-Philippe Rantin, Head of Pre-Sales Application Security. Good afternoon, Jean-Philippe, who will present you the challenges and benefits of automation. This session is recorded. You will receive a link during the day offering you the replay of the session. For the fluidity of the webinar, we propose to answer all your questions at the end of the presentation, and you can ask them throughout the webinar in the chat tab. Now I just have to let Jean-Philippe start the presentation and have a good webinar.
Hello, thank you, Amaury. I will be your speaker today. I'm Jean-Philippe, the head of pre-sales for the application and cloud security. I'm working for Roden Schwartz Cybersecurity, and I will be very happy to go over this topic today with you about boosting your cloud native application with automation. The idea today and what we are going to cover is first a short introduction to the cloud automation and its benefits. Second, we'll see how we can implement automation while securing your APIs and application in the cloud. Then we'll see how we can help. I mean, what Roden Schwartz Trusted Application Factory can do in this loop. And we'll have a short demo showing CI/CD integration within the product, and then we'll conclude and we'll keep some time for question and answer. So regarding the introduction to the cloud, there is ideal benefit, and when we are talking about cloud automation, in fact, what we should keep in mind is anything that is related to the way that you will push your application in the cloud and make it available. The benefit that you have in this environment are a digital transformation of the existing application. So whether you started a fresh deployment, whether you're going to take one monolithic type of application and you will decide to rebuild this application to make it a cloud application. So going to the cloud will gain agile deployment. So this is the benefit of going to the automation. The flexibility in terms of pricing and the total cost of ownership regarding this application when it runs, as well as when it is developed and built. You will as well gain in scalability and flexibility whenever you will need. You will optimize the resources because you will, I would say, by nature, not store anything or host anything in your environment, but you will try to push actually out every hardware needed to run the specific application. You will take the benefit of using as well the on-demand availability. So you will take the best part of the resources. So anything that is not needed will not actually be used, and you will only consume what you need. And you have a large savings in terms of cost, as we said, because this is as well part of the automation. And let's talk about the automation and how we can actually deploy those automation. Which type of environment can you choose to deploy this automation? So the first that probably come to your mind is the legacy environment. So what we call basically the private cloud. So in the private cloud, you will choose the private cloud if you have instances that should run 24/7, and that requires a lot maybe of hardware or a lot of maintenance around it. So this is something that you might want to have in your own cloud, so that you can actually maintain them, have a look at them, as well as saving costs, because this is something that needs to run 24/7, and that's probably the cheapest way that you can deploy in the cloud an application that should run in this with this frequency. Then you should as well, or you can take advantages of what we call the hybrid cloud. The hybrid cloud will be a combination of this private cloud that you will have on one hand, and the usage of a public cloud with a bit of overflow that can actually be routed to this extra maybe public clouds temporarily whenever you need. For example, when you have an exceed in the traffic, then you can actually overflow your environment and go into this public cloud environment in order to take advantages of the scalability of the service, where you will actually not plan or provision it in advance, but you will be more on a model of pay-as-you-go model, using the technology and buying or paying whatever you are actually consuming, and not in advance, which is probably what you are doing when you are using the private cloud. So if we summarize it, the multi-cloud and hybrid cloud scenarios take the advantages of different technology, and they are completely agnostic in terms of technology that you can deploy in each of them. But they all have their own flavor and their own advantages. So if we summarize, private cloud will be the favorite one for 24/7 running applications, while the public cloud is more like a pay-as-you-go type of usage. And in between, you will have a mix of both worlds with the hybrid cloud, and most customers today goes for this usage. They are using actually both worlds. So your application must be somehow able to use this different type of environment, and being able to be deployed in those different type of environments. So this is actually what we're gonna see now, is how do I use this, or how do I use this the best part of those type of environment. So usually you do it by the way that you can you will deploy your application, and by deploying this application, we can actually notice two major steps: the build and the run. So in the build step, you will usually use different tools that will allow you to script the deployment. That's what we call the infrastructure as code. And with that, using, for example, the Terraform script in order to build the application, and maybe then the Ansible script for configuring the application, you will be able actually to start and to build the environment and deploy it somewhere. So once it is deployed and configured, obviously, you can use either script in order to add then the second part, which is actually what you need during the run environment, which is at least testing and security. So for those two, you have you must have as well, like the build environment, a kind of deployment as code or configuration as code built into the technology. So this is actually where the trusted application factory starts, and we will see that in details in the coming slides. But this is what we are trying to explain: is when you start with automation and you are starting to actually build and deploy all your application in the cloud, you need everything to be able to be configured and deployed as code. And this is where we are heading to. One of the important things talking about the automation globally is definitely the scalability. You can scale vertically, you can scale horizontally, and it is two different types of scaling, reach in two different manners. Usually, if you scale vertically, then you will increase the capacity of the instance. So you need somehow to be able to change your subscription in order to be able to load a new type of VM, a bigger one if you need more CPUs, more RAM, more gigabytes in terms of usage. On the other side, sometimes you don't need more CPU because maybe your application usage is limited to a certain number of CPU or cores that you can use. But maybe you need to actually scale horizontally by adding some more instances. That's the case sometimes in order to absorb the load when the traffic loads can be spontaneously heavy, then you will actually scale horizontally in order to accept or to absorb this traffic. So thinking about your automation, you have as well to think about how can I monitor and be able to actually scale whenever I need into my traffic. And this is definitely part of this automation thinking that you should have. So what do we call a native application? So if I actually summarize what I've talked about just before, this is actually a summary of what we mentioned before. So the first thing is, of course, to be natively designed for the cloud. So it should be able to be deployed in the public, in the private or hybrid cloud natively. The second thing is the nature of DevOps by default. So it should be built with DevOps in mind, development and operation in mind. And it should be a collaboration between those two teams, maybe a merge of those two teams, in order to push your release and to create your application. It has as well to think and involve continuous integration and continuous deployment, what we call the CI/CD loop. And in order to be very flexible and scalable and all of this, normally it will reside on microservices and containers. So that's usually the underlayer that you will use in this type of deployment and automation in order to be very agile in terms of loading and deploying your application continuously, as well as continuously scaling if you need. So this is all of these different bricks that are required in terms of scalability. And you understand here that the very important layer is not anymore only the virtualization, but as well as usage of the containers and microservices. So if the containers are so important, why are they so important? The first thing is the isolation of execution of the code. So this is the one thing that is bring by using the containers generally. So you have a single operation that can be supported for each different container that you will deploy. So each container's got its own functions, and then you can actually scale them based on your need. The same way, each container can be created from different horizon and different kernel. So you can as well protect those different containers based on what you've been using inside each of them. So the isolation is one good point for using this container. The second is the application processing. So containers support easy and autonomous scaling. This is, let's say, a build as is type of application. So it is included in the container program to be able to scale. So you have a lot of built-in functionalities that you don't have to actually think about when you go for the usage of containers, and you just need actually to reuse what have been think and already built into the product. The second is you can then focus on what is going to be the east-west traffic and the communication between each microservices that you will be using, and how you are going to protect those different microservices in between the application that you will develop. That's what we call the DevSecOps operation. So you are adding security into your DevOps environment, and you are able to do so to shift left because you already have all those different bricks that are pre-built into the product that will actually save your time to focus and add more security in your application. Finally, it will improve the deployment and will push you to a faster execution. People usually using now DevSecOps, instead of releasing one application a year, they can actually release application every day. They can even sometimes, for some of them, make several releases the same day. You don't have to look after the kernel. You don't have to update the OS. It's all built into the container. You just need to load the latest container whenever you are building your environment. So this is actually very practical, and it helps you to improve and reduce the time to production. Usually speaking, the construction of the containers are better than if you are loading a full VM because it requires less resources to run, and the mobility is higher, so agile environment. So based on that, you will understand that this is definitely the way to go, right? It's to use containers. And what about using everything as code then? We talked about the infrastructure as code as a model. So the infrastructure as code will assume the fact that you will automate the build and the run phase to be pushed everything into the code without any human interaction. We talked about some tools like Terraform that can do so. Then the second step will be to configure what you push, so the configuration as code. For that, you will actually configure all the application or microservices or containers that you pushed using the infrastructure as code. You will now use them without any human interaction as well to configure them. And the best tool probably for that is Ansible. It's one of them. So why not thinking about security as code? You already have the infrastructure, you have the configuration for your app. So why not having this extra insurance that will actually be the insurance when you go live, that your application is secure enough and protected enough against any threats. So with the security as code, you will be able to define or check the context, install or put any firm security into your application, deal with false positive management, and improve the usage of your application. Or whenever the application is pushed to the internet, immediately it is well protected. You don't need any extra production step in order to make your application secure on the web. The idea is really that, and it's to automate as much as possible. So when you actually automate as much as possible, You have, during the build phase, the ability to use the product, then to implement some testing phase towards the CI/CD pipeline. Then you go to the release, then to the deployment phase. So in all of those different phases, you are able to use the security, or to integrate security in order to improve your application, and to together with the release of each iteration of your application, releasing a better version of your application, including security. So you can actually now use the versioning capacity of a CI/CD pipeline with the security that is as well built into your solution. So usually, most customers are already using SAST or DAST tools in order to check that the containers that they are using are secured. So what about including into your deployment as well your ability to be protected against the OWASP 10 activities on the web, and produce an application that is already safe. So that's about the Trusted Application Factory and what the Trusted Application Factory can actually do specifically for you. We do have different form factors of using our product on the internet. We have the traditional, I would say, or the legacy Rohde & Schwarz web application firewall that you can, of course, still use and deploy as a gateway in front of your application. They do exist. They can be deployed either in physical or virtual appliances. They can be as well deployed in the cloud using automation. We do have API and SDK for those API that you can use in order to deploy your RSWAF application into AWS, Azure, or GCP. It's something that still reside and exist. If you don't want to deploy anything or to manage anything, then we have as well a flavor of our WAF application, but in the cloud, already pre-installed, that we are calling the Rohde & Schwarz Cloud Protector. So this is a flavor of our application that resides as a software as a service usage. You will redirect your traffic to this application, so you don't need to change basically anything except maybe your DNS. We are using CNAME for that, and then we will clean the traffic for you before it goes to your application. And finally, we have the one that we are right now talking about, is the Rohde & Schwarz Trusted Application Factory that actually scale together with a cloud native application that needs automation. So that's the one designed for microservices, the protection of the microservices, and the scalability required by using those type of technology. So how can we help with the Trusted Application Factory? I mean, what can we do in terms of security? First of all, we are using our well-known and proven technology in terms of analysis. So we do have different engines in terms of scanning the traffic, your web traffic going to your application. So we are going to use the same technology, so you will have the same level of security as the one that you have when you are using the RSWAF on-premise. So we have a consistent application security that can secure against all the threats going to your web application. The OWASP 10 is only one of them, but you can have as well different type like account stuffing and all those type of threats. It's as well using microservices, let's say power, which is the ability to scale together with your application. In fact, the Trusted Application Factory will reside just by your application, depending on your infrastructure. If you're using Kubernetes, for example, you can deploy it in different manner in order to be as close as possible as your standard deployment, and include it into your CI/CD. The delivery is, as we said, easy. It's a container, so you can actually pull this container from our registry and include it in your infrastructure as code. So whenever you push something to the cloud, you can actually pull as well our image and build it together with your application, with always the latest image that is available. Finally, the pricing is very flexible. You have two types of usage. It's you can have the freemium for dev, for testing, or pre-production if you would like to test and try the product. And we have a premium version that is paid per request and per application per month. So you can actually be very scalable as well on the pricing, and the pricing can change, I mean, every month on your needs. So how do we add security into your deployment? So we can actually interact in different phases. We can interact during the building, during the test and the running phase. Usually you will have someone from the DevOps team in charge of the security, so that kind of DevSecOps member that will produce the configuration for the trusted application factory. We'll commit and then push it to the Git repository and start the build phase. During this build phase, you will start then the test performance, and you will perform the different tests. You can actually, based on the type of error that you get, stop the build and fix them before it goes actually to protection. Then if it's correct and there is no error, you can go to the next step, which is the run environment. So as well, when the application will be running, you still have included in your application this trusted application factory that is built into your application now, and will protect the application when it is live on the internet against all the threats that you usually know, like the SQL injection and any other threats from the OS 10. So how do we actually reach this goal? So in order to do so, we had to change a bit the way that we are handling the conception of the workflow. So for those already used to our workflows, we were using some specificity in the workflows, some IDs when you define or create a workflow for a specific application that will actually stop us from easily move a specific workflow to another application without changing a lot of different parameters. So the first thing was to actually differentiate two things into the workflows, which is what is the rules that you would like to apply against the specificity. What makes those rules specific to a specific application. So that's actually what we did when we built the workflow for the trusted application factory, and we ended with two different configuration files. So you will have one YAML file that will be in charge of defining the context with the workflow parameters and the specificities that will be assigned to a specific application. And on the other end, you will have the pure workflow part, where you have only the decision that you take against the flow and the traffic when it goes in and out of your application. So both can be actually now configured, or should be now configured separately into the trusted application factory. This is how we actually do that now. So why using the workflow as code? The first thing is we tempted to make it easy to use by using a Go syntax. So with the Go syntax, it will appear a bit clearly for you what should be modified, what should be added, or what should be removed whenever you are actually creating your own workflow. Doing this workflow, it will generate a security policy that will generally looks like what you used to work with, like your workflow. You know, if is there a threat, yes or no? If it's a no, then you go left. If it's a yes, then you go right. So the way of thinking stay exactly the same. Instead of having this URL view, you have UML view. Now you have actually you have to code it. It's just as code. This is the difference between those two. It is as code, and it actually gives us a bit of more flexibility in terms of usage, because you are now able to stick to the commits and the audits that you can apply into your CI/CD pipeline. So you can actually commit files for review, and then when it is audited and validated, then it goes to release, it goes to production. So the way that we build the application is really to be able to be integrated in a CI/CD model and to be able to respect the automation that you put in place, or that you will put in place into your next generation of cloud application. So let's see now quickly a video that will summarize what we've talked about and show you a bit of the product. So if I look into the CI/CD here, you can see I have my CI/CD pipeline in Git. Here is the YAML file for the configuration, so you can see that. I have here the scripts to build my Domi application. Together with in the build, or let's say the compose file, I have as well the build for the WAF, as the configuration for the WAF itself. And we do have the call of AppSec CTL in order to control the application, the trusted application factoring. So the AppSec CTL, we actually pass and load the logs that you can see, and from the logs we will be able to read if there is any exception that are needed when I'm creating or loading my application. So that's what I'm going to do now. I have, as you see, several branches into my application. I do have the master branch and a pre-production type of branch, where I can actually load my configuration, check for the exception. So that's what I'm doing right now, and I can, if needed, stop on any specific error. So you can see here the different errors that are specified. I can have a 200, I can have a 4, I can have 403. And depending on the type of error that I will receive, so this is my testing document. So depending on the return that I will receive, then either I build the application, either I stop right there. So let's keep on going with the demo. So I will choose here the app. So that's where I should call. If I have a 200, then it should actually show me that I can access the specific thing. Here I launch it the first time, and I saw that the test has failed. So I can check actually what failed into the test. And if I check here, I will see that exactly here, one of them actually did not went through. I can check what needs to be created as the exception based on the feedback from the log and the content that I got. And I can actually take the full frame here from the ints include it into my exception file. So I go back into my exception file here to deal with the exception. And here we go. This is the easiest way to basically deal with a false positive into your application. So the idea is really to not to make it difficult, but to make it easy for the DevSecOps team to include security into the application, into the CI/CD, stop if anything is wrong, but being able to build the application whenever the application is secured properly. So let's keep on going now and conclude. So the evolution of the automation have continuously improved and increased. It started from simple workflow that have been designed in 2010 to YAML file configuration in 2020, and this is definitely where we actually need to go. And this is where we are going, and this is what we're doing together. I mean, with the Trusted Application Factory. So you used to have the WAF application, Roland Schwarz legacy WAF. You used to be able to actually deploy this application using the API of the product into cloud environments if needed. And now you will be able to deploy it even closer to the application, built into your CI/CD, and avoid this validation phase that you usually have after publishing a new application. So you are basically what we call shifting left, saving time, and putting everything in the hands of one team. So in conclusion, why adopting the Roland Schwarz Trusted Application Factory? The first thing is to have a quick hybrid deployment between the on-premise and the SaaS. So that's the best way to do it. Is the ease of the deployments. It's very easy to deploy the product. As you saw, it comes as a container. It can be configured using YAML type of file, and together with your application, built into your CI/CD. So very easy to be integrated and deployed. The scalability is unlimited, just like your application, because it stands very close to your application. So there is no limits to the scalability of the application right now. It can be configured, so either you use it as is, there is a default workflow that is included into the product and deploy with the product. So either you just check the box and you put the minimum level of security, but at least you will be protected against the OWASP 10. Either you decide to actually go a bit deeper and work with workflow as code and inject your own configuration in order to reduce again a little bit more the frame of vulnerability of your application. Finally, the cost. It is simply cheaper than deploying anything else because you're saving time, and the licensing model is as well going with the freemium that you can use and the premium version when you are ready to go live for enterprise. Who is Roland Schwarz? Maybe should I quickly go over that and summarize. So Roland Schwarz is a technological group. It's German. More than 25 years of experience in IT security right now. We've been certified by many agencies, but probably the most known is the NATO that we are working with, classified as secret defense. The headquarters is in Munich, but we have a lot of competencies across Europe right now. And we have an office, or let's say 2 offices at least minimum in France, with others in Europe. We got a couple of award winnings on the technology. So the technology that will protect you against the OWASP and the threats is actually not new. This is the one that we are using. That is proven, and you can see that with all the awards that we have here. In terms of logos and people knowing our company are using our technologies. There are many, as you can see here, in different domains. It can be banking, can be energy, health, pharmaceutical, insurance. We do have references in all those different domains. So if you're interested by our product and you would like to know who someone is using it in your domain, in your environment, we'll be very happy to share that with you. We'll be very happy to have a chat and to let you ask for our test and try the product. Finally, we'll go to the Q&A. I think we reached the time. So maybe we can.
Yeah, we will take a 5 minutes session for. Is your solution compatible with Kubernetes?
Yes. So the solution is coming as a container, as we said. So basically, you can use it in any container type of environment. So that can be Docker, can be Kubernetes. And you will pull actually the image into your environment and use the product.
Thank you. We have a second question, which is, does it provide east, west, and north-south protection?
Yes. So talking about the Kubernetes environment, probably because the east-west and north-south is this type of environment. So the east-west will be can be ensured. We are actually able to deploy the product in 2 different ways when it comes to Kubernetes. It can be either in a sidecar or it can be inline. So depending on the way that you will use or deploy the application, you will be able to protect the east-west traffic, so in between 2 microservices, or the north-south type of traffic, so from the web to your application.
Thank you. And you just answered another question, which was which integration modes in Kubernetes are supported?
Yes.
I have another question, which is, what is the licensing mode?
So the licensing model, we talked about it quickly. In fact, so you have the freemium version that you can use if you're a developer or you would like to try it in a pre-production type of environment, play with the product and see how you can be protected. And then when you are ready to go, you can buy the license. You have to pay by number of requests and number of applications that will use the Trusted Application Factory.
Thank you. Last questions. We have 2 questions. You can answer them in one single response.
Yeah.
Can we find out more about what Rodentraut Cybersecurity offers in terms of DevSecOps, and how can we use, test Trusted Application Factory?
Yes. So for those 2 questions, we do have a DevSecOps community website. We will definitely encourage you to go and connect to this website. You can ask questions, access videos and documentation from this space. We will give you the address in a thank you email that we'll send to you after this webinar. But feel free, to connect and ask your questions and download the product as well from this area.
Thank you, Jean-Philippe. In order to respect the timing of the webinar, we will conclude this session dedicated to cloud native application automation. Thank you all for your participation. The replay of this session will be available later today, and we will send you by email, and you will be able to watch it as many times as you want the replay. The next webinar will be on Thursday, November the 18th, and this webinar will focus on managed services. We will show you how Rodentraut Cybersecurity manage your security from A to Z without you needing to deploy resources. So thank you again, Jean-Philippe, for your great presentation.
Welcome.
Thank you everyone for participating, and see you for the next webinar.
Bye.
Bye.